All right, welcome everyone. In this video, we are still going to concentrate on how to calculate for variance and standard deviation. But this time, we are not going to look at it on using a raw data. We are going to look at it with a frequency distribution table. Now, for frequency distribution table, we have the group frequency distribution table, and then we have the ungrouped frequency distribution table. Now, with this video, we are going to focus on how to calculate for variance and standard deviation on the ungrouped frequency table. Then we would later look at the grouped frequency distribution table. Let's look at our first example. Okay, so this is a typical example. Now let's assume that this example, let's take it from the angle that this is a sample frequency distribution table. Okay, now when you are given a frequency distribution table, the formula for calculating for variance and standard deviation differs in a way. So first of all, let's look at the formulas that you can use when you are handling a frequency distribution table. So for frequency distribution table the variance formula will differ when the data is a sample data, and it will also differ when the data is a population data. So let's look at the formula. So for sample data, this is the variance formula you are going to use. Sum of f into bracket x minus the mean all squared all over sum of f minus 1. If it is a population data, this is the formula you are going to use. Okay, so when you are handling a frequency distribution table, remember, this time we are not going to deal with a raw data. This time we are dealing with a frequency distribution table. The frequency distribution table, it could be a group frequency table or ungrouped. For example, this table is an ungrouped frequency table, ungrouped. Ungrouped frequency table. Why? You see, the variable columns are not in class limits or intervals, and that is how you know. Is that okay? Now, if you are given a frequency distribution table and you are asked to calculate for variance and standard deviation, once you are able to identify from the question that it is a sample data, the frequency distribution table is a sample data, automatically write this formula down. Okay, so the variance formula in a frequency distribution table, when it is a sample frequency distribution table or data, you use this formula. So variance is equal to sum of f into bracket x minus the mean, close the bracket, all squared, all over sum of f minus 1. Now, if the question tells you or specifies that it's a population data, this is the formula you are going to use. So variance is equal to sum of f into bracket x minus the mean, close the bracket, all squared, all over sum of f. So check the difference. You see here for the sample data here, the sum of f here is the same as n. So there are times that in some books they will do sum of f into bracket x minus the mean squared all over n minus 1. It's also correct. And there are some books that you see sum of f into bracket x minus the mean squared all over n. That is also correct. So it's either you are using this, or you are using this, or you are using that, and you are using this. They are all correct. So remember, if you are given a frequency distribution table, do not write the raw data formula. Do not write this formula. Sum of into bracket x minus the mean squared all over n minus 1. Or the sum of x minus the mean squared all over n for the population. And then for sample. When you are given a frequency distribution table, do not write these two formulas. In a frequency distribution table, these are the two formulas. So once we give you a frequency distribution table and the question asks you to calculate for variance, even if you don't know anything, at least write the two formulas. Once the question you're able to identify that it's a sample data, at least write the formulas down, because the formulas will always come with some marks. Now that we know the formulas, let's go back to our example. Okay, so this is our example. So this is an example of an ungrouped frequency table. Remember, ungrouped frequency table. How do you know it is ungrouped? You check the variable column. You see the variable column, they are not in intervals like 1 to 2, 3 to 4. You see the variable column are not in any class limit. So this is an ungrouped frequency table. Now, the moment we give you an ungrouped frequency table and you are asked to calculate for variance, the first thing you have to do is to write down the formula. So you write analysis, then you write down the formula. This one is a sample frequency table. So the formula will be, variance formula will be sum of f into bracket x minus the mean bar squared all over, this is a sample data, so sum of f minus 1. So you write down the formula. Now, the moment you write down the formula, pay attention to the formula very well. From the formula, you are going to see that you need the mean. Again, from the formula, you are going to see that you need the deviations. Fx minus the mean. From the formula, you are going to see that you need sigma, sum of f from the formula. So we are going to come over table. Sum of f means sum of all the frequencies. So here, sum of f from the table is 13. Okay, the other component of the formula is the mean. Now, anytime you are given an ungrouped frequency table to calculate for the mean, remember, we did this previously. If you are given an ungrouped frequency table to calculate for the mean, you are going to redraw the table again with an additional column called the fx. Okay, so you have to add another column we call the fx. But remember, once you introduce this x, it means this variable column, you have to name it x. So you write x over here. Then here become fs. Now from the formula, we will need this part of the formula too in the table, the deviations. So one column in the table will represent the deviations. So x minus the mean squared. Then one column from the table to represent the f times the deviations. Okay, so remember, anytime you are given ungrouped frequency table to calculate for, you are given ungrouped frequency table to calculate for the variance and standard deviation, the first thing to do is you state the formula. So variance formula is equal to sum of f into bracket x minus the mean close the bracket squared all over sum of f minus 1. And sum of f is the total frequency. We have that over here. Then remember, because we need the mean, we have to add the f of x. Okay? And because we need the variance, we have to add the deviation. So this represents the deviations. Then because of the formula says sum of frequency times the deviation. Sum of frequency times the deviation. So you have to introduce this column to f of into bracket x minus the mean, close the bracket, or squared. Okay, so now let's do the f of x. F of x simply means that when you take each of the frequency, multiply it by the variable. So 5 times 2 will give you 10. 2 times 4 will give us 8. 1 times 6 will give us 6. 5 times 8 will give us what? 40. Okay? Then now you do the sum of f of x. That will give us 64. Is that okay? Now, when you do this, this is very helpful, or this is going to be useful because this one is going to help you to calculate for the mean. Then you write the formula for mean. Mean formula is equal to sum of f of x all over sum of f. So this is the mean formula in a frequency distribution table. Sum of f of x all over sum of f. So this formula represents the mean formula in a frequency distribution table. Now, the reason why this has to be done quickly before you move on is because if you don't do this, you can't do this column. And you can't also do this column. If you don't calculate for the mean, you can't move on to the next, step by step. So you first of all have to calculate for the mean. So let's do the mean together. So sum of f of x will give us 64 all over what? 13. And that will give us 4.923. Okay, so now that we have the mean, we can now compute for the deviations. Okay, so over here, all it means is that the deviation, what it means is when you take 2, you subtract the mean from it, then you square the answer. When you take 4, you subtract the mean from it, you square the answer. When you take 6, you subtract the mean from it, then you square the answer. When you take 8, you subtract the mean from it, then you square the answer. So let's start over here. So 2 minus 4.923 squared. Okay? Let me create more space over here so that we can write the answer. Then here, you are going to get 4 minus 4.923 squared. 6 minus 4.923 squared. 8 minus 4.923 squared. So do the summation for all of them. So here will be 8.544, okay? 0.852, 1. 9.468. So now we have the deviations. If you've gotten the deviations, now the next column says that multiply the deviations here by the frequency. So here, f, that is f of x minus x bar, close the bracket square. So when you take this deviation, 5.544, then you multiply by 5, then you write the answer here. You take the 2, you multiply by 0.852, you write the answer here. You take the 1, you multiply it by the 1 point. So here is going to be the same, 1.1599. Okay, let's do for the first two. 5 multiplied by 42.72. Then 2 multiplied by 0.852. 1.708. Then 5 multiplied by 9.468. 47.34. Okay. Now, after you've gotten here, check. You do not need this, the sum for this. Because according to the formula says sum of f, sum of the frequency times the deviation. So it means that you don't need the summation of this column. You need the summation of the last column. Because the numerator says sum of f times the deviation, meaning we need the summation here. So you come and do the summation. So sum of f, so here you can put dash over here. Then you come and do the sum of f into bracket x minus x squared is equal to 92.93. So after you've gotten this, you are halfway through. You are good to go. So you reference back into the formula. You go back into the formula. This is the formula. And this is the top one that we've gotten. So 92.93 all over. It's a sample data. The frequency distribution table is ungrouped, but it's a sample data. So that's why the formula, the denominator, we have sum of f minus 1. Sum of f is 13. So 13 minus 1. So we are going to get 92.93 all over 12. And that will give us 100.6, no, 92.93 divided by 12. Good, 7.744. So this is the variance. So after you've gotten the variance, if you want to calculate for the standard deviation is equal to square root of what? The variance. So that's square root of 7.744. And that will give us 2.783. So let's go over everything again. So here we are looking at how to calculate for variance and standard deviation in a frequency distribution table. This example is an ungrouped frequency table. How do you know it's ungrouped? You check the variable column. The variable column is not in limits or intervals. So this is a frequency, ungrouped frequency table. Now, if you are asked to calculate for variance and standard deviation in ungrouped frequency table, the first thing you have to ask yourself, the data, the frequency data, is it a sample data or a population data? Here, it's stated that it's a sample data. So it means that you are going to use the frequency formula for variance and standard deviation, but then you would use what we call the sample formula. And the sample formula is sum of f into bracket x minus the mean, close the bracket squared, all over sum of f minus 1. We are using sum of f minus 1 because it's a frequency table, but it's a sample data. So you use this formula. Now, from the formula, you are going to see clearly that you need the mean. Okay, you need the mean. Before you calculate variance, you need the mean. Again, the formula will also let you know you need the sum of what? F. So you come to the table. The sum of F means the summation of all the frequencies. Then you do it and keep it down. So sum of F is equal to 13. Now, the formula also says here means we need the mean. Now, how do you calculate for mean in ungrouped frequency table? You introduce another column we call f of x. So remember that anytime you are asked to calculate for variance in a frequency distribution table, you need to introduce 3 new columns. Especially when it is an ungrouped frequency table, you need to introduce 3 new columns. So the first column is the f of x. The second column is the x minus the mean, close the bracket squared. Then the last column is the frequency times the deviation. This column is what we call the deviation column. And this column is the frequency times the deviation. Frequency times the deviation column. Okay, so anytime you are given ungrouped frequency table to calculate for variance, these 3 columns are compulsory. 1, 2, 3. So f of x column, deviation column, and frequency times the deviation column is compulsory. If it was to be a group frequency table, we would need 4 new columns. One column will be for the midpoint. The other column will be for the f of x. The next column will be for the deviation column. And the last column will be the frequency times the deviation column. So there are 2 principles here. If it was to be a group frequency table, we will need 4 columns. The first column will be the midpoint column. Okay, the second column will be the f of s column. The third column would have been the deviation column. And then the last column, which is the fourth, will be the frequency times the deviation column. But here, this is ungrouped. Ungrouped, you don't need the midpoint column because the x is already here. So here, we only need 3 columns. The f of s column, Why f of x column? Because of the mean. The reason why we have the f of x column is because of the mean calculation. Okay? The reason why we have the deviation column is because of the variance. And the reason why we have the f of the deviation column is also because of the variance. Is that okay? Great. So we did our f of x. Then we have to do the sum of f of x. So the sum of f of x, why are we doing sum of f of x? Because in mean formula for frequency distribution table, mean in frequency distribution table, mean is equal to sum of f of x all over what? Sum of f, or sum of f of x all over n. So remember, the formula for mean in a frequency distribution table is sum of f of x all over sum of f, or sum of f of x all over n. Is that okay? And our sum of f of x is 64. That is what we have over here. Sum of f, which is the total frequency, is 13. That is what we have over here. Then at the end of the day, the mean is 4.92. After you've gotten the mean, you can now move on to the deviation column. So the deviation column said x minus the mean close the bracket squared. So you do the deviations for all the x values. For all the x values. So 2 minus the mean, then you square the answer. 4 minus the mean, then you square the answer. 6 minus the mean, then you square the answer. 8 minus the mean, then you square the answer to get all the deviations. When you finish, remember at the deviation column, you do not need the total for the deviation column because the mean formula in a frequency distribution table, the numerator, you only need the sum of f, not the sum of x. You need the sum of frequency times the deviation. Is that okay? So it means you will need the summation for the f times the deviation. Then you come and do the f times the deviation. What that means is that when you take the frequency, then you multiply by the answer you had for the deviation. So 5 times 8 point this, then you get this. 2 multiplied by 0.852, you get this. 1 multiplied by 1.599, you get this. 5 multiplied by 9.68, you get this. Is that okay? Then you now do the summation. You sum all up. You sum all of them up. Then you get the sum of f into bracket x minus the mean squared is equal to, then we had 92.93. Now, after you've done this, it means you are halfway through the getting closer to the variance. Then you reference back into the variance formula. Okay, so the variance formula says that sum of f of x minus the mean close the bracket all squared all over sum of f minus 1. Okay, now the sum of x minus the mean close the bracket squared, that is what we have over here. This is it. Then you come and write it over here. Okay, you write it over here like this. Then you have 13 minus 1. The 13 minus 1, where from it? The denominator of the formula says sum of f minus 1. Sum of f is 13. So 13 minus 1, that will give us 12. So at the end of the day, the variance is 7.744. When you get the variance, standard deviation is equal to square root of variance. Is that okay? Standard deviation is equal to square root of variance. So standard deviation is equal to square root of 7.744. Then you get 2.783. Then you are done. So now we will look at how to calculate for variance in in a group frequency distribution. In a group frequency distribution. Okay, so let's do a typical example. Let's use the same age. Okay. So let's look at this example. So for this example, this is a typical example of a group frequency table. Grouped. So this is a typical example of a group frequency table. And we are going to use it to learn how to calculate for variance. Now the question is, how do you know it's a grouped frequency table? You check the variable column. And you can see clearly the variable column, we have class limits or interval. So it tells you this is a group frequency table. Now, the moment you are being asked to calculate for variance and standard deviation in a typical statistics question, the first thing you do is you write down the formula. Okay, but here we are looking at a frequency table. So you write down the formula. So variance formula is equal to sum of f into bracket x minus the mean squared all over. But this one, let's assume this is a population data. Let's say this is a population data. So if it's a population data, it will be sum of f. If it was a sample data, then we use sum of f into bracket x minus the mean squared all over sum of f minus 1. This is for sample. This one is for population. Okay, so let's assume this one is a population, this table is a population data. Now, here, take note that this is a group frequency table. Once it's a group frequency table, you've been asked to calculate for variance. You will need certain additions or adjustments on the table. So the first column you are going to create is the f of x column. Sorry, the midpoint column. Because why the midpoint column? Because see here, we don't have x over here. Because it's class, there are class limits. It's a group frequency. There is no x column. So you need the s column. In this kind of table, the s column is what we call the midpoint column. So the x, or the midpoint, or what we call class midpoint. And the class midpoint is equal to the upper class limit plus the lower class limit divided by 2. So here you do the midpoint column. The next column you need is the f of x column. The next column you need is the x minus the mean, the deviation column. The next column you need is the frequency times the deviation column. Once you are able to add all these columns, you are halfway through. So in fact, even if you don't even know anything, just by demonstrating that you are aware that you have to go through this process, that one alone also comes with some marks. Even if you don't know anything, by stating the formula and being able to competently demonstrate that at least these are the columns that have to be created, that one alone will give you some marks. Is that okay? Yes. So in statistics, you don't always need to solve everything to arrive at the final answer before you gain enough marks. Just by demonstrating some competence on some of the things that have to be done, it comes with some marks. Okay, great. So now we will need the midpoint. Let's work on the midpoint first. So the midpoint, you add 5 plus 1 or 1 plus 5 divided by 2. That will give us 10 plus 6 divided by 2. That will give us 8. 15 plus 11 divided by 2, 18. 16 plus 20 divided by 2, 18. Okay, but before, let's do the sum of f. Sum of f means sum up all the frequencies. 6, 11, that will be 12. So now let's come to the f of x. F of x simply means that, so here the midpoint is our x now. So 2 times 3, that will give us 4 times 8. 5 times 13. And here will be 18. So then we don't need summation of the midpoint. You can put dash there. But we will need summation of the f of s. Why? Because of the mean. Okay, so you do sum of f of x is equal to, so you sum up, that will give us 1, 2, 1. Okay, now that we have, you can't continue. If you don't finish with the mean, you can't do the deviation column. So you quickly have to pause and finish with the mean. Okay, so you see, if you're able to follow this systematic process, you realize that it becomes very simple for you to arrive at the final answer. So now you state the mean formula. Mean is equal to sum of f of x all over sum of f. So sum of f of x will give us what? Sum of f of x, it gave us 121 divided by 12. That will give us 10.08. 10.0. So now we have the mean. So it means once we have the mean, we can now do the deviations, right? But remember that the midpoint is now the x. Okay, so the deviation, you use the midpoint and then the mean. So we have 3 minus 10.08 squared, 8 minus 10.08 squared, 13 minus 10.08 squared, 18 minus 10.08 squared. And remember, you don't need total or summation for the deviation column. You can put dash there. Is that okay? Great. Then now you come and do. So let's do the summations for the deviation. Now you have 74. The first one. You have 50. The first one. 1.3. The second one. And third. The last. Okay, so now we have all the deviations. Then you come and do the frequency times the deviations. What that means is when you take 2, you multiply by the answer you had for the first deviation. When you take 4, you multiply by the answer you had for this deviation, 7.84. When you take 5, you multiply by the answer you had for this deviation. When you take 1, you multiply by this. So I think we can do the last one. That will still be 7.92. So let's do for the 3. So 50.13 times 2. That will give us 100.26. That's a 1.36. And 5, 42.65. Then now we need the summation for this column. So sum of x minus the mean squared. That will give us, so you do the summation for all. 180. 182.19. Is that okay? Yes. So now the moment you get this, you've done about 75% of the work. Then you reference back to the variance formula again. Remember, we established that this calculation, we are looking at a population beta. So the variance will be equal to, the top part is this. So 182.19. You don't have to restate the formula again. We stated it in the beginning. Over here, we are not going to do sum of f minus 1 because we say we are using the population data. So it's going to sum of f. Sum of f from the question is 12. Then you write over 12. So our variance will be equal to, come again, 15.183. Then now if you want the SD, SD is equal to square root of the variance. Okay, so SD will be equal to square root of 15.183. SD will be equal to 3.897. Is that okay? Good. So now let's go over, let's summarize the whole thing. When you are given a grouped frequency table to calculate for the variance, it's very simple. First of all, write down the variance formula. It will come with a mark. But you have to ask yourself some questions. The group frequency table that has been given, is it a population data or a sample data? If it is a population data, this is the formula you are going to write. This is the formula you are going to write. If it is a population data. If it is a sample data, this is the formula you are going to write. If it is a sample data. This time, the question is a sample data, so we use this formula. Is that okay? Yes. Now, it's a group frequency tables. So remember that there is no X column. There is no S column. So you have to introduce the S column, and that is what we call the midpoint column. Okay, so for group frequency table, if you are asked to calculate variance, you will need 4 additional columns. The midpoint column, the F of S column, the deviation column, and the frequency times the deviation column. In a group frequency table, if you are asked to calculate for the variance, you need 4 additional columns. The midpoint column, the frequency column, the deviation column, and the frequency times the deviation column. Okay? So the midpoint column, how do you get a midpoint column? You add the lower limit plus the upper limit. You divide by 2. So 1 plus 5 divided by 2, you get 3. 6 plus 10 divided by 2, you get 8. 11 plus 15 divided by 2, you get 13. 16 plus 20 divided by 2, you get 18. Then you do the midpoint column. You will not need total for the midpoint column. Put dash there. Okay? Then you come and do the F of S column. Why do you have to do the F of S column quickly? If you don't do the F of S column, you can't do the deviation column. You can't also do the frequency times the deviation column. So now we quickly do the midpoint. We've done that, the frequency column. So the F of S column means you multiply the midpoint by the number of patients or the frequency. So 2 times 3, we get 6. 4 times 8, 32. 5 times 13, 65. 1 times 18, 18. Then you sum up all the F of X to get F of X, sum of F of X. That is 121. So after you've gotten the sum of F of X and then sum of F, you can calculate for the mean. Because for frequency distribution table, the formula for mean says that sum of F of X divided by sum of F. And that is what we have over here. Sum of F of X divided by sum of F. Then we have 121 divided by 12. So this is our mean. This is our mean. So typically, if unit was given, you have to add a unit. So here will be years. Okay? Now, after we've gotten the mean, we can quickly come to the deviation column. Now, remember that here, it's not on group frequency table, it's grouped. So you will not go and use the S over here. The S, you'll be using the midpoint. Okay? So the deviation, when you take the midpoint, then you subtract the mean. So 3 minus the mean, then you square. 8 minus the mean, then you square. 13 minus the mean, then you square. 18 minus the mean, then you square the answer. Then you get all the deviations. After you've gotten the deviations, the last column is the frequency times the deviation. So 2 times the answer you had over here. 4 times the answer you had over here. 5 times the answer you had over here. 1 times the answer you had over here. Then you do the F of the deviation column. Then you need this one because this summing up all this represents the numerator of the variance formula. So this is the numerator of the variance formula. Is that okay? Great. Then you see, so we sum up all these. We had 182.19. That is what we've written over here. 182.19 divided by 12. 182.19 divided by 12. Then we had 15.183. And that is the variance. Now, when you get the variance, to get the standard deviation, you just find the square root of the variance. And that is what we've done over here. So the standard deviation is 3.87. All right, so thank you so much for following up to this time. So this brings us to the end of variance and standard deviation.